Hello, welcome back to Nick Does Maths. I'm Nick, this is Maths, we're going to do it. What have we got? We have a 3x3 matrix which has some gubbins in it, including a k, which is not brilliant to show with. Show that a characteristic equation for m is this cubic in terms of lambda and k. We're then told what the determinant of m is, find k, etc, etc, etc. All right, well, let's get going. So characteristic equation. Characteristic equation comes from setting the determinant of matrix minus lambda identity to 0. So we need to sort out this determinant. 1 minus lambda, k minus 2, 2 minus 4 minus lambda, 1, 1, 2, 3 minus lambda. Won't lie, a little bit sketchy about this. There's a lot that can go wrong here. Right, let's just go along the top row. So we're going to get 1 minus lambda times the determinant of our minor down here, which is minus 4 minus lambda, 3 minus lambda minus 2, minus k times the minor, which is 2 times 3 minus lambda minus 1, plus, but there's a minus there anyway, 2 times this determinant, which is 4 minus 4 minus lambda. Set that to 0. Let's just take our time. I think this is going to require a lot of border erasing and a lot of space. What's this give me? Lambda squared minus 3 lambda plus 4 lambda is plus lambda. Minus 12 minus 2 is minus 14. Minus k times minus 2 lambda. 6 minus 1 is plus 5. Plus 2 times 8 plus lambda. All right. Minus lambda cubed. Oh, do you know what? I cannot be doing that. Let's not get overly fancy. Let's just expand it bit by bit. So 1 times that bracket minus lambda times that bracket times out the k here, plus 2k lambda minus 5k plus 16 plus 2 lambda is 0. Okay, what does that give me? Let's pick out the lambda cubed term, minus lambda cubed. Pick out the lambda squared. Well, actually, they go away. So let's pick out the lambda terms. So what do we have for the lambdas here? Got 1 lambda, 15 lambda, 17 lambda. Ooh, that doesn't feel good. What is going wrong here? What have I expanded? Because I'm looking for 13 lambda. I'm looking for 13 lambda. I'm also looking for 2k lambda, which I've got. So that's okay. But that's okay. So I'm looking for a minus 13. Ideally, I would quite like this. Aha! Because that's a minus 2, isn't it? That's a minus 2. There we go. Hopefully that fixes the world for me. Let's find out. So 1, 15, 13 lambda. Plus 2k, so that's good. And now my numbers, minus 14 minus 16 will give me a minus 30 minus 5k. And if I just flip all the signs, we will get the required result. Pull a 5 out from there. which is kapow, kapow, what we were looking for. Okay, step 1 done. So that's nice. That's very, very nice. Let's find k. Right, well, we know the determinant of m, right? We know the determinant of m. And in fact, what I'm going to do is I don't want to redo the entire thing, right? I've done all the hard calculation. This here, this line here, that is the determinant of m minus lambda I. So if I whack in a lambda equals 0 into this line, if I whack in lambda as 0, I just get the determinant of m, right? If you put in lambda as 0 into here, like that, equal to 0, you get the determinant of m. So, not going to go in here, because here I multiplied everything by -1 and be out by a negative. But here, this is still, at this point here, all I've done is the determinant. So that is my expression. So minus 30 minus 5k. What are we told the determinant is? It's 5. So what does that tell me? Minus 35 is 5k. It tells me that k is minus 7. Okay. Okay. K is minus 7. Awesome. Awesome, awesome. So what I'm going to do is, I need a little bit of space on the board. So let's get ourselves, number 1, our characteristic equation. So my characteristic equation, lambda cubed minus, so let's put k as minus 7 in. 13 minus 14. 13 minus 14 is minus 1, so that is lambda cubed plus lambda. Put in k is, yeah, we're in here, right? Yeah, 13 minus 14. Put in k is minus 7, minus 1. Minus 5 is 0. That's very, very, very handy. And just remind ourselves k is minus 7. All right, let's make a little bit of room here. Man erases whiteboard. 50 million views on YouTube. Okay. Now, what we know is from the Cayley-Hamilton theorem is that my matrix itself does also satisfy its characteristic equation. That's what we know. So it tells me that m cubed plus m minus 5 times the identity. We do need to put that in. Don't just put minus 5, otherwise you'd have matrix, matrix, and scalar. All right, that is the slight modification to the characteristic equation. And what we're going to do is we're going to times the entire thing by the inverse. So I end up with m squared plus the identity is equal to, and I'll just move that over to the other side. There we go. And now we just need m squared. Now, won't fib. I might just sort that out a little bit. Do I still have? Yes. This is where having a calculator that will do matrices for you comes in very, very handy. By all means, we know the value of k is minus 7. You can do m squared all by your lonesome if you want. I do not mind. All right. So what do we end up with if we tidy all of that up? I'm going to say, so what is m minus 1 then? I'll get a minus 14 over 5. I'll get a 17 over 5. I'll get a minus 15 over 5. I'll get a minus 5 over 5, which is minus 1. I will get a 5, because 4 plus 1 is 5 over 5, which is a 1. Minus 5 over 5 is a minus 1. Oh, minus 9 over 5. And 10 over 5, which is a 2. And there we go. Not that bad, actually, that one. The one key trick that I think is quite useful is if you've already found your characteristic equation, I mean, you do have to keep track of what you did to tidy it up to get to here. But when you then want to find the determinant of m, remember fundamentally, this comes from an equation. Just keep track of your working, and if you just put in lambda equals 0 in, you just get back to det m. That's what I thought was quite cool about this question. It's a fairly, at the end, it's a fairly straightforward, this last part, a very, very straightforward use of the Cayley-Hamilton theorem, but there we go. Still fun for everyone. I hope you enjoyed that, minions. I'm Nick. This was a bit of maths. Do not forget to like, subscribe, hit the bell so that you don't miss a single one of these amazing maths episodes. I'm going to go now. Bye.